Alright, so today I just want to go ahead and do a little more progress on here. I'm working on this Python thing on Free Code Camp. So, I'm into algorithms now, and I don't really know these algorithms because this is my first language that I'm learning. So I don't have like previous experience or knowledge come into this. All I got to do was read this here about binary search. And I did the binary search workshop. That wasn't too bad. But I have no idea what bisection search, merge sort, quick sort, selection sort, or loon are. I watched a YouTube video last night, actually a few of them, to see what these three are. Actually, these four, but I didn't watch loon. So I think probably the best bet is going with the search merge sort. I think will probably be our best bet because I took a look at those labs and I just don't know. I don't know those algorithms, so I'm gonna have to do more research on those. But I want to try and knock one of these out of the way. Um, so let's see here. Merge sort. Merge sort is a sorting algorithm that uses the divide and conquer principle to sort collections of data. That is, it divides a collection into smaller subparts and conquers the subparts by sorting them independently, then merge the sorted subparts. Begin by creating a function called merge sort. So, so we'll define our function. Um, Takes the parameter array. I need to move this. Okay, so it takes the parameter array. This function will handle the task of sorting a list of numbers. Use the pass keyword for now. Okay, got it. The merge sort algorithm performs three actions: divide an unsorted sequence of items into subparts, sort the items in the subparts, and then merge the sorted subparts. So yeah, I remember seeing this in the video. And if I'm correct, essentially if we have a list of numbers, we'll say, for example, we'll do like they've got a 4, a 2, a 7, a 10, a 1, and a 5. I was doing an odd number. We'll also add in a 6. So it'll pick a middle part. Now I'm going to do this manually because because I don't know how it would really work if it's just random. So say we do the same list, but we put our 5 in the middle because that's where we want it. Not true. 4 we'd want 6, 7. No, that's right. 6, 6, 10. Be like that. Right? And our 5 is in the middle. Now it's going to merge sort by sorting these first and sorting these. So it essentially make a list of 4, 2, 7, and it'd sort them so it'd be 2, 4, 7. Then we got our 5 here. Then we've got our 1, 6, 10. Sorry, our 10 actually would not be here. Our 6 would still be where it is. The 10 would be, would be like this. And it'll essentially it'll do this. Then it'll mix our what do you call them, subparts. So it sorts the items in the subparts. So these are sorted. Now it's going to merge the sorted subparts. So it's going to look at the first here and the first here, and it's going to say that 1 is the first. Then it'll look at 2, 6, and say that 2 is next. Now it'll look at 4 and 6. It'll say that 4 is next. Then we know that 5 is already here. Then it'll look at 7 and 6, and it'll go 6. Then it'll look at 7 and 10, pick 7, and then it'll return 10 as the last. So then that way it sorts this list into a sorted list. So essentially that's what we're doing, if I'm correct. Um, so first replace the pass keyword with the variable middle point. Use the integer division operator to divide the length of the array by 2. So it'll be length of array divided by 2. Assign the result to middle point. Indent your. So why is this wrong? Do I need to have spaces or clear middle point? Oh, I made a typo. In the previous step, you got the midpoint. You can use it to divide the array into 2. Assign each part to new variables. Use the slice syntax to extract the left half of the array and assign it to a variable name. So we're going to call it left part. And how do we do this again? Asking for the slice syntax to extract the left half of the What happens when we doesn't really give us any more information? I really don't know. How do we get this left? Let's see. Left side of an array is identified by calculating the middle index and taking the elements from the start of the array up to but not including them. Yeah, but how do we understand that? Okay. Floor I minus. We don't have I. We don't have a lower. That'd be our left and our right. Okay. Slice the array. Okay. 0 array. Okay. 0 of index. Okay, so we want to take the index. Was there even slice? I think that we even use the slice. We're going to take our input parameter of array. So it equals array of index 0, so the beginning of the array, to our middle point. That is what it wants. Okay. It's going to ask us for right part. Variable name looks like it's going to be our right part. So essentially, it should be the same thing, but in the array, it'll be middle point, then our semicolon. Awesome. Now you've divided the array list into 2 separate lists. So keep dividing each list until every element stands alone in its own list. A list with a single number is always sorted. Right, got it, okay. To do that, recursively call the merge sort inside your function. We're going to call merge sort. Keeps on doing it. Pass left part to the call. Now, I just want to test something real quick. If we give array the value of, we'll do like what I did earlier. So 4, 2, 7, 6, 10, 5, 1. If we do something like this, I'm gonna copy this so we can, because it'll probably erase this. And then we'll print. Oh boy. Alright, we're gonna figure that for now. At the bottom of your function body, call the merge sort function again. This time pass the right. Yeah, took away my right, so good thing I. Now it's time to sort and merge the lists. Part my part. Original list. You can do this by comparing elements on both lists and merging the smaller element to the main list. We're going to do this comparison for all the indexes in left part and all the indexes in. We have to create 3 variables: left array index, right array index, and sorted. Set the values to 0. Okay. Guess these have to be inside. Must be a scope thing. Okay, so next you need to create a loop that continues as long as there are elements remaining in both left part and right. That create a while loop. Imagine this could still be inside. While 2 conditions. So we're going to either have an and or an or. Checks whether the left array index is less than the length part. So while left array index less than length of part. Another that checks. I guess we can go with and. Oh, it probably would be or. I'm gonna say it probably would be or. Or right array index is less than length of right part. Okay, it is and. Both conditions are true. Both conditions are within the while loop. That's with the if statement. Checks if the element in the left part less than element the right part. No, I just want to understand. So our left array index is 0. That is less than the length of our left part, which we had in our situation. We had seven integers in our. So pick a middle point, and then put 3 in our length of left part and our right part. So essentially, if 0 is less than 3 and 0 is less than 3, run this. If 3 is less than 3, that's what we got right now. Oh. Okay, I see what I did wrong. We're just gonna thing. Our left part index left array whole thing if that is left the right part. That's just ugly. I'm gonna just to here we go. Oh no, I'm gonna just come back here. That fixes what I had. I had this right, but I can't go back to the last step too. Here we go. So that's for the if statement, not for the while. If our left part at index left array index, if this value is that, then this is just bugging. So ugly looking when it splits the lines like that. When the if condition evaluates to true, it means that the element in the left part is smaller than the element that is being compared to in the right part. Okay. So in that case, you can put the element found at the left array index in the part within the sorted array. That is if the left part is smaller. So to do that, left part at index, left array index. Sorted. Now after assigning that left part to the sorted, increment left array index. So left array index plus equal 1. First step, you assign the element with the left part because it was smaller. But this will not always be the case, right? Because it depends on the input, how many inputs. So in some comparison cases, the element on the right could be smaller. Right, so I feel like this would happen if there's an even amount of inputs. Like if the list has, say, 6 inputs instead of 7. I was doing 7. I felt like it'd be easier having true midpoint. But with an even amount, it's kind of like picking the median of a number set with 6 numbers. Median, you would pick the 2 numbers in the middle, add them together, and divide it by 2. Find the average of the 2. This computer, I think, will just choose the largest of the two sometimes. I think that's the scenario where the left side would be larger than the right side. So we're going to create else clause. Maybe here. I think this is else. We're going to do the opposite. So this is catching for the opposite scenario. The condition. So we go with left. If that's not true, if it's not right, then we'll do the right instead. And then we're going to do the same thing by incrementing by 1. So now we're going to right array index. Set that equal to plus equals 1. Array index plus 1. The if and else statements you created in the previous step will assign elements to the sorted array. Right. Okay. Each element assigned to the sorted array takes up the index in the list. You have to move the next index into the sorted array. Each assignment below the if else block, still within the while loop. Increment sorted index. While loop you created compares one element from left part with another in right part, then adds the smaller element to the main array list. We'll continue this operation until there are no elements left to be compared. But left part may still have elements left, the right part has none, and vice versa. Right part may have more elements, the left part has. So create another while loop. This is going to run while left array index less than length of left part. The next step is to use it to copy the remaining elements in left part into the array list. Okay. The while loops code block assign left part of left array index to array sorted index. So array of sorted is going to equal left part index. Still within the while loop, we're going to increment the value of left array index by 1. Last thing to do for the while loop is to move the index in the sorted array. So it's going to be sorted index plus equals 1, and then we did another while loop. I'm going to replicate the same while loop logic for the right part. Well, if that's the case, then we're just going to do this. Right part. Right. There. Now we have the mirrored image for our left and our right. For testing the merge sort function, you need to create a base case. It stops the function execution when the length of array is less than or equal to 1. So it's going to be an if statement. If, so it's going to be, what is it? If length, okay. You create a base case that stops the function length of array less than or equal to 1. Okay. After the function declaration, create an if statement condition. Within the body of the if statement, add a return. They learned in the previous lesson, you can use the name variable to determine if Python script is being main program or being imported as a module. If name equals create a list called numbers. Yeah, we're just gonna copy this for time's sake. Oh, code failed. Must be an index. Maybe this has to be okay. Wrong. The value name is set to main. Oh, maybe equals right. Now the indentation is wrong. The indentation was originally. I just didn't have. I think we want this regardless. It's printing. What's wrong? My space was taken away. You want an if statement. Call the print function again to print the number list. We'll print the unsorted list. So print again. Unsorted array. This is our unsorted. Perfect. Wow. Twice in one run is kind of crazy. I don't think I've ever had this happen. Twice in one activity. After your print calls, call the merge sort. And pass in the numbers list as now we're supposed to be inside if. I guess we do want it to be in if. Everything here I want to be in if name equals main. True. All these carry out this list of actions. At this point, numbers list has been sorted. Now we need to call it. So we call print what? Print merge sort. I'm going to string says sorted array. Followed by another print statement to print the sorted. We have our unsorted array. We have our sorted array. So that's it, huh? Now I want to. I guess that's all done, right? Yeah, that's it. So now I just want to do. I'm just gonna do this for now. I'm gonna delete this file for a second. I just want to see. Well, actually, let's rename this to sort. I keep this. So here we've got. This is what's gonna be running, right? Name equals main. It doesn't equal main. This is sort. Name is gonna equal sort, but that's okay because we're not actually running this. I want to try and look at this in full scale without instructions breaking up my code. I want to be able to see it all in one view. So we give it our numbers, right? And it's going to tell us the unsorted array. And it's going to sort the numbers and give us the sorted array. So it's going to call this merge sort, and merge sort is this whole block of code here. You can actually get that. Now we're just going to look at what we've got here. So we've got an if statement. So I guess I do. So if the length of array is less than or equal to 1, return. We break out of the function. We want an escape, so we're not just stuck in a loop. Okay, so that's what this is doing here. We're breaking out if there's only one number or 0 numbers. So if this was empty, then it would just escape out. So this is just ensuring that there are multiple inputs, 2 or more, that needs to sort. Because if you had, say, like a 10 and a 14, sorry, rather, I guess a 10 and like a 1, then that would need sorted. That's not already sorted numerically. So even with 2 numbers, this would work. But we're going to define a middle point, which is the length of array divided by 2. So since we have 1, 2, 3, 4, 5, 6, 7, 8 numbers, is that right? Yeah. Divide that length by 2. And what does it actually pick? One, two, three. Well, we'd have to actually break it up and look at it between the steps because we actually still don't know if it's the 5 or the 6 as the. What if we, before we sorted them, we printed our middle? what if we take this line then put it up here? Four, two, one, 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 one. What's going on here? Guess it's because it's well, I couldn't get what I wanted to get that, but that's fine. So it's going to put our left part is everything that's on the left side of those numbers and side. So say, I guess really it's gonna break this in half. So I'm gonna choose between 14. I don't know which one it's taking. Say for example, it takes 14 though. We're gonna have 4, 6, and 10 as our left part. We'll have 2, 1, 8, 5 as our Jesus. We're gonna assume it's 14, but it could also be. I don't really know. Because that's what I was trying to figure out just now. And I couldn't figure out an answer to that. But we're gonna merge sort the left and the right. So it'll sort out. So it'll be 4, 6, 10 it would return. And then it'd be 1, 2, 8, 5. Actions. And well, it's in less than length of our left part. Left part would be 3. So if 0 is less than 3 and right is 0 is 4. So this is 3 and this is 4. Well, this is true. And if left part of index 0, I see. Now I understand the purpose of the. The left part is going to be 3. So if our left part list of numbers, the length actually, it wouldn't even be 3. Would be this. This would be. This is a list of numbers 4, 10, 6. Left to right index 0, so it'd be 4. If 4 is less than right part, right part 0. 4 is less than 2. Put it in array 0, which our array is. It is. Doing it. I guess we don't have array defined anymore. I guess we don't really need using array, which would be left part. Sorry. This is recursion calling the function inside the. So it's gonna choose, I guess, array. We could call it 4, 10, 6. Of sorted index would be index 0. That would be 4. 4 is equal to left part index. Oh wait. So whatever the value is of our 0 index, which would be 4 is equal to array of sorted index. Still not understanding where this array is from. I guess that's not totally necessary. Then it's going to increase the index by 1 and repeat with the next thing. We can do 4, and then move on to the 10, do that, go to the next one, 6. Put that state. Then we have the same thing else going for the right side. And do the same thing over here, 2, 1, 8, 5. Keep moving on. Then this here, we've got a left array index. Well, our left array index, so the index less than left part. Our left part 3. So 3 numbers here. We want to run this code array at the index of sorted. We're going to set it equal to the left part of our index. So setting 4 left right index plus 1, then it moves on to 6. Well, 10, then 6. This is the sorting, and we have the same thing with the sorts the. Then how do we have it combined the two? Where's this happening where the left and right are together? Calling the word sorts them. Still kind of not really understanding that, but I guess maybe I'll have to do some more research, some more reading, and some more maybe like an animation that can explain it a little bit better. Put visualization to this code. Because somewhere in here I'm getting lost. I understand all of this and statement here, but somewhere in these two whiles I'm not really understanding where the left and right are merged together. I understand how the left side of the middle point, I understand how this left side is being sorted and how this right side is being sorted. I don't understand how they're being mixed together, sorted again. Because eventually we want this 1 and 2 to be less than first, then the 4, 5, 6, then 10, and we want 14, our middle point at the end. I don't understand where that's happening.